Okay, let's do this review on topic 1.1 to 1.6. This is the first video on this review. We are given a graph of the polynomial between -5 and 5, and the function has a local extrema at -2 and 2, and the graph has a point of inflection at 0, x equal to 0, which is right over here. If you're thinking it is a -1, yeah, it is y value, right? X is still 0, so 0, -1. On what intervals is the function increasing? That's pretty straightforward. The function is increasing means it is climbing, where it is going like this. Now it is declining or descending, or here again it is climbing. So I'm going to say that the function is increasing from -5 to 2. Sorry, not 2, -2. In fact, -5 can be included, right? Yeah, -5 to, but actually I honestly do not know whether it is going to take a turn after this or it's going to go like this. So usually these questions are given with an open interval. So it's -5 to -2, union 2 to 5. That's going to be the increasing. And are they asking decreasing? No. They're asking concave up. Sorry, concave down. Concave down is the frowning phase. So frowning phase is clearly right here till this point, because 0 is the point of inflection. So after that, it's a smiling phase. So that goes again from -5 to 0 all the way. All right. Over here, G is shown, G has point of inflection, which is -1, which is right over here, and 1, which is here. And on what intervals is the function G decreasing? So G is going down, declining is in this interval, then it is increasing, then it is decreasing here, and then it is increasing again. So it's from -5 to -3. Union 0 to 2, union 0 to 2 over here. That's where the function is decreasing. And on what intervals is the graph of G concave up? Concave up means smiling phase. So smiling phase would be something like this, because at -1 is an inflection point. So it is frowning here, and then it is smiling again from 1 onwards. So it is concave up from um, -5 to, let me just write here, -5 to -1. That's where it is smiling. Union 1 to 4, right? It ends at 4. Yeah, 1 to 4. Okay. Function of h is given, relative extrema at -3 and 2. Yes, we can see that. A point of inflection at x equal to -1. So right somewhere over here. On what interval is G increasing and concave down? Both. Okay. So it is increasing, where obviously it is climbing, something like this. This is all the way it is increasing. And in this green shaded portion, where is it concave down? So concave down is frowning phase. So clearly it is a smiling here till -1, because -1 is a point of inflection. And then it is frowning. So this region, which is from -1 to 2, is where it is, satisfying both the properties. On what intervals is G decreasing and concave up? So obviously decreasing is the remaining portion, which is here and here. This is decreasing, and they are saying concave up as well. So here it is a smiling only in this region, because this region is clearly it's frowning in nature, right? So they are saying concave up, but this arrow indicates that it goes all the way to -infinity. So my answer is going to be -infinity to -3. Okay. On what intervals is G decreasing at a decreasing rate? That's they're just playing with the terminologies here. Um, decreasing at a decreasing rate means concave down, basically. Decreasing rate is concave down. So they are asking which on which interval is it decreasing and concave down. So we just drew the decreasing thing, right? It was here and here. And concave down, this is obviously concave up. Concave down is this portion. So it is from 2 to infinity all the way. And increasing at an increasing rate means increasing and concave up. So increasing is something that we also drew earlier. Draw that again. So this is all climbing portion, and increasing rate means concave up. So clearly this portion is concave up, where this is just concave down. So it's from -3 to -1. That's the answer. Right. Over here, the graph of k is shown in the interval of -6 to 6, and the points labeled A, B, C indicate where the function k has inflection points. So determine each of the following is true or false. The rate of change of k, okay, AROC, is increasing over the interval 4 to 6. So AROC will increase if the function is, let's see, how is the function behaving. So 4 is here and 6 is here. So obviously AROC is increasing, right? Because AROC is, the rate of change is increasing, the ROC is increasing when the function is concave up, right? Rate of change increasing. They are not saying rate of change is positive or negative. They are saying rate of change is increasing. And ROC increasing means, in other words, they are asking whether it is concave up or concave down. So yes, definitely it is concave up. So it is indeed true. Concave up means increasing. The rate of change is negative. Now this is different. They are saying whether ROC is negative or positive. I hope you understand, you're not getting confused. See, ROC can have, uh, they can ask ROC in four ways. Either ROC is positive or negative or increasing or decreasing. If they say that ROC is positive, means the function is increasing. If they say ROC is negative, it means that the function is decreasing. If they say that ROC is increasing, then you will say the function is concave up, and here it is concave down. This is the scenario. So here they are saying ROC is negative. ROC is negative means the function is decreasing from -4 to 0. And -4 is here and 0 is here. Yes, absolutely. Yeah, the function is indeed decreasing. So that's true. Then they are saying that k is increasing at a decreasing rate. The decreasing rate is also a fancy way of saying it is concave down, right? ROC is decreasing as a ROC is going at a decreasing rate. That's the same terminology as saying it is decreasing. So that's concave down. So they're asking it is increasing and concave down in 2 to 4. Let's see. 2 is here and 4. Let me just clear that. So 2 is here and 4 is here. So it is not increasing anyway, right? It is decreasing, of course. So that should be false right away. Okay, then they are saying positive and decreasing over the interval -6 to -4. -6, let's first mark it. -6 and -4 is here. So ROC is positive. Yes, ROC is definitely positive because the function is increasing, right? ROC is positive means the function is increasing, so that's true. And ROC is decreasing means the function is concave down. That's also true because this is a downward cup. This is a frowning face. So this is absolutely true. Okay. The function is concave down in the interval -4 to 4. That's a pretty straightforward question. So concave down means here is going like, definitely that's incorrect. I mean, -4 to 4 is a big interval. And I can clearly see that from here, this is an inflection point. If you notice this portion, this is obviously smiling in nature. So it is not concave down. So that's false, of course. All right, more questions on the same curve. K is increasing in the interval -6 to 4, -6 to -4, sorry, -6 to yeah, it is increasing, and 4 to 6 as well. Yeah, 4 to 6 as well, it is climbing. So that's absolutely true. K is negative and increasing in 4 to 6. 4 to 6 is already highlighted. K is negative. Yes, K is negative because K is below the x-axis. Remember, they are not asking about ROC here. They are just asking whether the function is negative. Yes, the function is negative because it is below the x-axis. And is the function increasing? Yes, the function is definitely climbing in nature. So that's true as well. Next, they are asking in the interval -3 to 0. -3 to 0 is here, and then they are asking 2 to 4. 2 to 4 is here. They're asking k is decreasing. Yes, k is definitely decreasing. At a decreasing rate means concave down. I don't think so. This is concave up because this is smiling face. So that's false. All right, k is positive, negative 3 to 0. That's the interval. So I'd like to again highlight that interval first. So negative 3 to 0 is right here. It was already drawn. K is positive. Yes, definitely k is positive because it is above the x-axis. And the graph of k is concave up. Yes, it is concave up. No? This is smiling in nature. So yeah, that's absolutely true. K is positive between 4 to 6. So 4 to 6 is right here. K is positive? Well, absolutely not. How can K be positive? K is just negative because it is below the x-axis. There's not even any need to read further. All right. Over here in this question, the equations for the function f and the piecewise function defined by g are given, and selected value for the function k are shown in the table, and the graph of p is given in the interval. Excellent. So there is a function f, there is a function g which is piecewise, there is a function k for which they have given a table, and there is a function p for which they have given a graph. Oh my goodness. Find the AROC of fx. So be careful what you have to look for. Fx on 1 to 2. That's pretty straightforward, I think, because AROC, I think we know the formula by this time. AROC is f of b minus f of a over b minus a. F of b minus f of a over b minus a. So what is f of 2? Let's plug in 2 over here. So I think that's just going to be f of 2 will be 2 times 2 cube minus 2 plus 1. 2 cube is 8. 8 times 2 is 16. Um, 16 minus 2 is 14. 14 plus 1 is 15. And then what is f of 1? F of 1 is just 2 minus 1 plus 1, which is just 2. So I'm going to plug in the numbers here, which is 15 minus 2 over 1, which is just 13. That is AROC of this function. What is the AROC of fx is negative 2 to 0? Isn't that the same thing? F of 0 is the easiest to find, it's just 1. And f of negative 2 will be 2 times negative 2 cube minus negative 2 plus 1. So that will be negative 16 plus 2 plus 1, which is negative 13. So AROC, right now we are solving part B. So, I mean, sorry, question 15. AROC is going to be f of negative 2, sorry, f of 0 minus f of negative 2 over 0 minus negative 2. So that's, I think, 1 minus negative 13 over 2, which is 14 over 2, which is just 7. For 16, again, it's an AROC of G, but it is G this time, right? And G is this. So be careful because this is a piecewise function. So first I need to find the value of G of negative 1. So which function is applicable first off? Obviously, negative 1 is less than 3, right? X less than 3. And x less than 3, this function is applicable. So we just plug in negative 1 over here, which is going to be 4 minus 2 times negative 1, which is 6. And G of 4, 4 is the b, and 4 is obviously greater than 3. So this function is applicable. So which is 4 square plus 2. 4 square plus 2 is 16 plus 2, which is 18. So AROC is going to be G of 4 minus G of negative 1 over 4 minus negative 1, which is 18 minus 6 over 5, which is just, I think, 12 over 5. This cannot really be simplified further. Likewise, they're asking again G over the interval of 0 to 3 and G over the interval of this. So it's pretty much the same thing, just they are just changing the numbers, right? So for example, G of 0, once again, G of 0 means x is less than 3. So if we just plug in 0 here, I'm just gonna get 4. So it's just G of 0 is 4. And likewise, G of 3 is, be careful here, because where 3 is not included here, because if you see x is less than 3, 3 is included here because it's greater than equal to symbol. So if you put 3 here, 3 square is 9, 9 plus 2 is 11. So AROC is going to be 11 minus 4 over 3 minus 0, which is, I believe, 7 over 3, correct? Yeah. Question number 18. Again, it's the same thing. We just need to find -4. So -4 for g of -4 is again less than 3. If you put -4 here, that's going to look like 4 minus 2 times -4, which is 4 plus 8, which is just 12. And g of 2 is just going to be also less than 3 because 2 is less than 3. So both are actually referring to this function. So 4 minus 2 times 2, which is 4 minus 4, which is just 0. So AROC is going to be g of 2, which is 0, minus g of -4, which is 12 over, I hope you understand, I can just rewrite one more step. I can just write one more step, g2 minus g of -4 over 2 minus -4, which is 0 minus 12 over 6, which is negative 2, right? 6 to the 12, yeah, -2. All right. Then now we are moving on to K. K is, remember, the table, so that's going to be even easier because we just have to read the numbers. So it will be AROC is going to be K1 minus K -2 over 1 minus -2. K1 is, as you can see, at x equal to 1, K is 4. So 4 minus, at -2 it is 8. So 8 and 1 plus 2 is 3, so the answer is -4 over 3. 20, AROC of P. So for P, we need to refer to this graph. So AROC is going to be P of 5 minus P of -1 over 5 minus -1. So that's going to be, what is P of 5? Let's see. At x equal to 5, P is 3. So that's 3 minus P of -1, it is right here. P of -1 is just 1 over here. So 1 over 6. So 2 over 6 is 1 over 3. Right, I'm not gonna do 21. That's for you to try. If you would try and let me know the answer if you want to confirm. All right, moving on. We need to determine whether these followings are concave up, concave down, or neither. So obviously we need to see, we need to find the first difference, right? Because just with the first difference, I can figure out whether that's concave up or concave down. So for example, and yeah, just make sure that the x are increasing by the same quantity in all these three. And yes, it is, because in question number 22, it is increasing by 1 unit, and in question 23, 2 units, question 24, 3 units, so all good. So to find the first difference, you can just subtract these y values, final minus initial. So 4 minus 3 is 1, 6 minus 4 is 2, 9 minus 6 is 3, and this is 6. First difference is basically the rate of change. And as we can see that the rate of change is increasing, right? Because the numbers are 1 to 2, 2 to 3, 3 to 6, obviously the numbers are increasing. So this is concave up. Likewise over here, 1 minus minus 3 is 4, 7 minus 1 is 6. This is, I think, 4. This is 4. So there is no pattern here. It's like, it was like increasing first and then decreasing, then became constant. So actually it is neither, since there is no pattern. And over here, again, if you find the difference, this will be 7, this will be 5, this will be 2, this will be 1. So clearly the numbers are decreasing. So that must be concave down over here. Likewise for this one, again, x values are increasing with the same value, I think, in all these three. Yeah, it is. So good to apply. So -3 minus -5 is 2. 0 minus minus 3 is 3. 6 minus 0 is 6. 11 minus 6 is 5. So increasing, increasing, and then decreasing. So neither, no pattern. 32 minus 64 is minus 32. 16 minus 32 is minus 16. 8 minus 16 is minus 8. 4 minus 8 is minus 4. The numbers are increasing, right? I mean, on number line, a bigger negative number is a smaller number. So obviously the numbers are increasing here. So it is concave. Likewise, this will be negative 2, this will be negative 2, this will be negative 4, I think. Yeah, negative 4. This will be negative 8. So the numbers are decreasing. Obviously, the concavity is not changing from here to here, but eventually it is getting concave down because the numbers are decreasing. So just with these given values, I will say that it is concave down. Remind the least possible degree of the following polynomials. If you remember how we used to do these questions is we find the first difference, then second difference, and then third difference, and so on, till it becomes the same number, till we get the same difference, that corresponding difference. So let's say, for example, second difference is same, so it will be second degree, and so on. All right, again, making sure that the x values are increasing with the same amount. So yes, it is actually happening in all these. No, not happening for this, right? It's not happening over here. So we need to be a little careful about this one. But yeah, let's do the first three. Negative 3 minus minus 3 is 0. 1 minus minus 3 is 4. 8 minus 1 7. This will become 9. This will become 10. So obviously not equal. If you take another difference, this is 4, this is 3, this is 2, this is 1, not same. Third difference is negative 1, negative 1, and negative 1. Definitely, the third difference is same. So this is the degree, the least degree of this polynomial would be 3. Okay. Over here, 8 minus 12, negative 4. This will be negative 2. This will be 0. This will be 2. This will be 4. This is the first difference. Let's find a second difference. It will be negative 2 minus minus 4, which is 2. Here 2, here also 2, here also 4 minus 2, 2. Excellent. So degree is 2. Fine, let's try question 30. So first difference is going to be negative 5 minus 0, which is negative 5. Negative 7 minus minus 5 is, I think, negative 2. Negative 6 minus minus 7 is 1. Negative 1 minus minus 6 is 5. 10 minus minus 1 is 11. Second difference is going to be negative 2 minus minus 5 is 3. 3. Oh my goodness, this is 4. Huh, not lucky. This is, I think, 6. Let's find the third difference. I hope third difference we get lucky. 3 minus 3 is 0. Oh my goodness. 4 minus 3 is 1. 6 minus 4 is 2. Nope. Let's find the fourth difference. So I think finally we have the same number because 1 minus 0 is 1 and 2 minus 1 is 1. So the least degree is 4. Now this question is pretty interesting because although the x values are not getting increased with the same number, but if you notice, don't you think x and y values are just same? And if x and y values are just same, don't you think it will follow the equation y equal to x, which is just degree 1, right? Degree 1, that's about it. Actually, we know the answer, we know the equation as well, the polynomial, it's fx is equal to x. So the degree is just 1. Okay. Following function are even, odd, or neither. So if you remember, for even and or odd or neither, we used to replace x with minus x and see how's the behavior. If f of minus x also comes out as the function, then we call that as an even function. And if f of minus x basically throws the minus sign outside, then we used to call it as an odd function. Let's see 33. So f of minus x will be replacing all the x with minus x here. So this is minus x, this is plus 9. So from this, the minus sign comes out. So it will become minus 2x cubed. Here also minus sign comes out, plus 3x plus 9. But I don't think so. This is matching with the function, definitely. So it's not an even function because the function is different. Is this an odd function? Let's try to take a negative sign as a common factor and see if then we are getting the same function. But again, no, because this is minus 9 and the function has 9 in it. So actually it's neither even nor odd because both these conditions are not matching. In 34, we replace x with minus x. So this will become minus x raised to 4 minus 3. Obviously, minus will just become positive because it's an even power. So it will become x raised to 4 minus 3, which is again the same function. So this is an even function. And finally, we have 35. In 35, let's try to replace x with minus x. So g of minus x is going to be, okay, I need some space. So g of minus x is going to be negative 6 times negative x raised to 5 plus 2 times negative x cube minus of negative x. So all the negative signs will be thrown outside because they are odd powers. So double negative will become positive 6x to the 5, negative 2x cube and positive x. This is surely not the function, so it's not even. But if we take a negative sign out, I will be left with negative 6x to the 5 plus 2x cube minus x, which is definitely the function again. So this is minus of g of x, which is odd function. All right. Again, we have to find even or neither. This is easy because we just have to find whether the function is symmetric about y-axis or origin. So this is obviously symmetric about origin. The way you check the symmetry about the origin is basically you reflect this about the y-axis and then you reflect about the x-axis. So if you're getting the same function, then it is symmetric about the origin, which happens in the case of odd function. So this is odd. This is obviously neither symmetric about y-axis nor symmetric about origin. So this is neither. And this is clearly symmetric about the y-axis because if you put a mirror on the y-axis, it will basically form its mirror image. And yeah, it is a mirror image. So this is an even function. It's a clear overlap. Right. The polynomial k is even and p is odd. Selected values for the functions are given. Use the following to answer. What is the value of a and b in the tables above? So a is here and b is here. So if you remember, we talked about this in 1 I think 5 or 6, I think. But we said that if x comma y is a point on the function, let me write it like this. If x comma y is a point on the function, then negative x comma y will be a point on the even function and negative x negative y will be a point on the odd function. So basically, even if you change the sign of x, the y doesn't change. So if this is even and we are looking for a, so look at this point where the x sign is getting changed. Negative 3 just became 3. But the y will not change. So 8 will remain 8. So a is just 8. In B, likewise, here you can see that this 3 is here, so minus 3 is here. So 3 changes to, negative 3 changes to positive 3. So negative 4 will definitely change to positive 4 as well. So B is 4. Okay. What is K of 2? K of 2 is, here we know that K of negative 2 is negative 6. So K of 2 will also be negative 6 because we just discussed that even if you change the sign of x, as in make negative 2 to 2, the y doesn't change. So it will remain negative 6. P of negative 2. What is P of 2? P of 2 is 7. So obviously P of negative 2 will be negative 7 because both changes the sign. So this will be negative 7. So the answer is negative 13. What is k of negative 1? Likewise, k of 1 is 4. So k of negative 1 will also be 4. And what is p of 3? P of negative 3 is 2. So p of 3 will be negative 2 because sign changes. So this will become 2. And what is AROC in this? So of PX. So AROC, I'm just going to do over here. So AROC is going to be P of 5 minus P of negative 5 over 5 minus negative 5. P of 5 we do not know, but P of negative 5 is given as 4. So I know that if P of negative 5 is 4, then P of 5 will be negative 4 because the sign will change. So P of 5 is negative 4, and this is 4, and this minus is from the formula. 5 plus 5 is 10, so the answer is negative 8 over 10, which can be reduced as negative 4 over 5, I think. Yeah, that should be our answer.